Hello, welcome back. In this video, we'll write the name of some mononuclear coordination compounds. Let us
start without wasting time. First one, Cr NH3 whole 3 water whole 3 Cl3. You see the part present inside the coordination sphere, or you can say in the square bracket, is the cationic complex, and the ion outside the coordination sphere is the counter ion. This is the anion, and this part is the cation. And you should write the cation first, then the anion. And this is the complex part. This is the complex part. In the complex part, you see this is the central metal atom. In the formula, you have to write the central metal atom, then the ligands. But in the nomenclature, you have to write the ligands first with suitable multipliers, then the central metal atom. After central metal atom, we have to write the oxidation number as upper Roman numeral, then the counter ion. So here there are 3 ammonia molecules, so we should write triamine. Here double M is written, triamine. Then for 3 water molecules, it should be triaqua, then central metal atom chromium, then the oxidation number of the central metal atom should be written in parenthesis. Then 3 chloride ions are there, so we should write chloride. For information, you never have to indicate the number of cations and anions. Here there are 3 chloride ions, but here you have written only chloride. No need to write trichloride. Don't write trichloride. Number of anions should not be written, so only chloride is there. But number of ligands inside the coordination sphere should be written, triamine, triaqua. If it is a ligand, then the numerical prefix, or you can say suitable multiplier, should be written, triamine, triaqua, chromium. And here the oxidation number of chromium is 3 plus 3, so you should write Roman letter, upper Roman numeral, and that should be written in parenthesis. And the name is one word. Use one word. There should be no gap. Triamine, triaqua, chromium 3 chloride. And here I can write how do I get this upper Roman numeral. Let us calculate. For chromium, the oxidation number is X. For ammonia, it is 0. And for 3 ammonia molecules, you should multiply 3. Then for water, it is 0. And for 3 water molecules, we should add 0 into 3. And for chlorine, it is -1. And for 3 chloride ions, I should write 3. Then the total oxidation number is 0. So x plus 0 plus 0 minus 3 is equal to 0. So x minus 3 is equal to 0. X is equal to plus 3. So for plus 3, you should write upper Roman numeral 3. So triamine, triaqua, chromium 3 chloride. Triamine, triaqua, chromium 3 chloride. You see the name is one word, and the oxidation number is written as upper Roman numeral. It is written after this central atom in bracket, or you can say parenthesis, then chloride. And here there are 3 chloride ions as counter ion, but here it is written only chloride. No need to write trichloride. Number 2, CO H2N CH2 CH2 NH2, then bracket ends, moon bracket, then 3, then square bracket ends, 2, then sulfate. You see, this is the counter ion and this is the cationic part. The cation part is a complex one, and here S2N CH2 CH2 NH2 is EN, ethane 1,2 diamine, you know, CH2 CH2 and 2 NH2 bonded to this CH2 CH2 group. So it is a bidentate ligand, and it is also written as En, and it is kept in bracket, you see. Then this is the central atom. In the formula you see central atom is written first, then the ligand. But in the nomenclature you have to write the ligand first, then the central atom, and number of ligands are 3 over here, so you should write tris. Usually we write for 3 tri, but here it is tris because it is a bidentate ligand and written in parenthesis, so you should write tris. Tris means 3. So tris, and this part is ethane 1,2 diamine. You see here you have to write single M, and ethane 1,2 diamine should be written in bracket or parenthesis. Then there is no other ligand, so central atom should be written cobalt. Then the oxidation number should be written as upper Roman numeral. Then the counter ion, don't need to write trisulfate, don't write trisulfate because ions should not be written as such, it should be written as sulfate. But here you see there are 3 ligands inside the coordination sphere. It is indicated before the name of the ligand, and here you see the ligands are written before the central atom, but in the formula you see metal atom is written first, then the ligand. So you see this is written in a reverse way. Tris ethane 1,2 diamine cobalt sulfate. But here the oxidation number can be calculated. For CO it is X. For ethane 1,2 diamine this is 0, and for 3 ethane 1,2 diamines we have to multiply 3. Then there are 2 cationic parts, so we should multiply 2. Then plus, for sulfate it is -2, and there are 3 sulfide ions, so we should multiply 3. Then the total charge is 0, so X plus 0 into 2 plus -6 is equal to 0. Then 2x for 0, no need to write anything, -6 is equal to 0. Then 2x is equal to 6, x is equal to plus 3. So here we should write upper Roman numeral 3. Then number 3, Ag NH32 Ag CN2. You see here cation is complex, anion is complex. Here both cation and anions are complex, and we have to find the oxidation number of this central metal atom first. X for ammonia it is 0 into 2. For this Ag, X for cyanide it is -1 into 2. Total charge will be 0. So x plus 0 plus x minus 2 is equal to 0. 2x minus 2 is equal to 0. 2x is equal to 2. X is equal to plus 1. So the oxidation number of x is plus 1. For this Ag is also plus 1. Then you see Ag NH32 plus 1 means the charge on it is also plus. For Ag CN2 this is plus 1, this is -1, so plus 1 minus 2 is equal to minus. So Ag NH32 plus Ag CN2 minus. For this one it is +1, for this one is -1, for 2. Then the cation is named first. Here you see the metal atom is written first, then the ligand. But here we have to write the ligands as prefix with suitable multiplier, means 2 amine molecules are there, so we should write di. For ammonia it is diamine, and you see there are 2 M's, diamine, and there should be no gap. Then silver, for silver the oxidation number is +1, so you should write upper Roman numeral diamine silver 1. Then this part will be written here. We have to write the cyanide ligands first, and there are 2 cyanide ligands, so we should write di. For cyanide this is dicyanido argentate, then oxidation number +1, so it is written as upper Roman numeral. And here you will see this is silver over here, but this is argentate, and At is for anionic complex. At is for anionic complex. At is for anionic complex as a suffix, argentate. If there is an anionic complex, the metal atom is suffixed by the group of letters ATE. So this is diamine silver 1 dicyanido argentate, and you see the name is one word. Di is the multiplier, or you can say numerical prefix before the ligand, and here the ligands are written first, then the central atom, then the oxidation number as upper Roman numeral. And here there are 2 parts, cation and anion, both are complex, so again the anionic complex is written as dicyanido argentate 1. Next one is number 4, PtNH32, Cl NO2. You see here the central atom, then ligands written alphabetically. This is amine, this is chloride but written as chlorido, this is nitrite, nitrito N. You see A is written, then C, then N. So this is PtNH32 Cl NO2, and this is a neutral complex because there is no counter ion, and the charge on it is 0 because nothing is written over the square bracket, so it is a neutral complex. And the central atom is written first, then the ligands, Here in this case we have to write the ligands with multiplier as prefixes. You see this is amine, but the 2 ammonia molecules, so I should write di for these 2. Then for these 2 ammonia molecules we should write diamine. For this chlorine it should be chlorido. You see this is chloride, but here E is written as O, so this is chlorido. Then this is nitrite N, nitrito N, nitrite, so it is written as nitrito, nitrito O, then N for this nitrogen, diamine, chlorido, nitrito N. Then central atom platinum, then its oxidation number is 2, that you can calculate. For ammonia it is 0, for chlorine is -1, for it NO2 it is also -1, for it is bound to be +2, so it can be written as upper Roman numeral. So diamine, chlorido, nitrito N, platinum 2. But here you have to remember one thing, between this N and this P, one hyphen should be written, one hyphen should be inserted, one hyphen should be inserted. So this is N, then a hyphen, then platinum 2. Diamine chlorido nitrito N hyphen platinum 2, and this is one word. And you see this is the central atom. Before the central atom, you see the ligands are written alphabetically. How you see? A, then C, then N. A, C, N. A, C, N written alphabetically. And for two ammonia molecules, di is the numerical prefix, or you can say multiplier. Number 5, K3 Cr C2O4 3. This is the cation, this is the anion. So cation is written first, then the anion. First you should write cation, then the anion. In the complex part, you should write ligands alphabetically, then this central metal atom, then oxidation number in bracket as upper Roman numeral. So here we should write potassium, then the complex part is CrC2O4 Here there are 3 C2O4 ions, so we should write potassium tri oxalato, potassium tri oxalato, potassium tri oxalato, potassium tri oxalato. The oxidation number of chromium can be calculated first. For potassium it is +1, and there are 3 potassium ions, so +1 into 3. For chromium it is X. For C2O4 it is -2 into 3 is equal to 0. C2O4 means CO minus 2 negative charges are there, so it is C2O4 2 minus, so +3 plus X minus 6 is equal to 0, +3 minus 6, it is X minus 3 is equal to 0, so X is found to be +3. So the oxidation number of chromium is found to be +3. So let us write the IUPAC name of this mononuclear coordination compound. First we have to write potassium, then the complex part you have to write the oxalate ion first. Here you see this is oxalate, so you should write oxalato. How many oxalate ions are there? 3. So you should write potassium trioxalato, then chromium, but here chromium is written as chromate, so this ion part will be replaced by a group of letters, that is AT, chromate, potassium trioxalato chromate. Then the oxidation number of chromium is +3 here, so you should write upper Roman numeral 3, potassium trioxalato chromate 3, potassium trioxalato chromate 3, potassium trioxalato chromate 3. Next, number 6,
CO, Cl2, En2, then counter ion chlorine.
you see the cation is written first, then the anion. Here the central atom first, then ligands, but in the nomenclature ligands are written first, then the cation, then oxidation number, then counter ion. So you should write the oxidation number first, or we should calculate the oxidation number first. For CO it is X, for chlorine it is -1 into 2. For En you know, this is CH2 CH2 NH2 ethane 1,2 diamine. Its oxidation number is also 0 into 2. For chlorine it is -1 is equal to 0, or X -2 plus 0 minus 1 is equal to 0. So X minus 3 is equal to 0. So X is equal to plus 3. For this it should be written as upper Roman numeral. Then let us write the nomenclature. So 2 chloride ions are there, so it should be written as chlorido. So I should write dichlorido. But here it is a bidentate ligand, and there are two bidentate ligands. For these two we should not write di, we should write bis. If 3 bidentate ligands are there, then we should have written tris. If 4 such bidentate ligands will be written, then the numerical prefix or multiplier will be tetrakis. So for 2 chloride ions as ligands, it is written as dichlorido. For 2 bidentate ligands, I should write bis ethane 1,2 diamine. Here you see single M, and this ethane 1,2 diamine should be kept in bracket, bis ethane 1,2 diamine. Then ligand part is finished. Then the central atom is cobalt. We should write cobalt, and the oxidation number is +3, so we should write upper Roman numeral. Then for this chlorine it is chloride, dichloride of bis ethane 1,2 diamine cobalt 3 chloride. CO NH3 whole 5, CO NH3 5, then CO3 in bracket, then bracket ends, then Cl is the counter ion. Here this is carbonate, so carbonate is written as carbonato. This is ammonia, but it should be written as amine, and this is central atom. The oxidation number CO for CO is X, plus ammonia it is 0 into 5. Why? There are 5 ammonia molecules. For carbonate it is -2, so we should write -2 into 1 is equal to, and for this chlorine it is -1, total 0. X plus 0 -2 -1 0, so X minus 3 is equal to 0. X is found to be +3. For cobalt this is +3. Then what to do? We have to write the nomenclature, and you know in the formula you have written central atom first, but here in the nomenclature you have to write this part ligands first in alphabetically. You should write alphabetically the ligands, because this is amine and this is carbonato, so S should be written first. That I have already discussed. So for 5 ammonia molecules we should write penta amine. You see double M is written here, penta amine. Then for CO3 it is carbonato, carbanato, then central atom cobalt, then oxidation number 3, pentamine carbanato cobalt 3, then chloride, you can give gap over here, no problem, because this is the complex part is written as one word, pentamine cobalt 3 chloride. Then number 8, Hg CO SCN4. Here this is the counterion Hg, cation, it is mercury. Then for 4 thiocyanate I can write tetra, for S thiocyanato, mercury tetrathiocyanato, then central atom cobalt, but here the complex part is a negative charge complex, so it is an anionic complex. So anionic complex should be written in a different style. Here the central atom is suffixed by at, so cobaltate. You see, for anionic complex the central atom is followed by at, cobaltate. Then the oxidation number is +3, that you can calculate, so it is written as 3, mercury tetrathiocyanato cobaltate 3, here at is after the central metal atom for anionic complex. For cationic complex, the central metal atom cobalt is written as cobalt, Pt is written as platinum. But for anionic complex, the metal ends with at. For example, for cobalt it is cobaltate. For iron it is ferrate. For silver it is not silverate. This is not silverate, this is Latin name argentate. Here Latin name for silver is used, argentate. For aluminum it is aluminate. Thank you for watching the video till the end.